Today we're going to talk about molarity. Molarity is a measure of concentration, and we do that in moles per liter. So concentration is just simply, think about like making Kool-Aid or adding sugar to a cup of tea. Um, and however much you add, you could measure, and usually with something like tea or Gatorade or Kool-Aid or something, we just say, oh, we've added 2 spoonfuls. But we need to be more precise in chemistry class. And so therefore we have this measure called molarity. Um, and so you just take the moles of solute and put it over the liters of solvent. So solute is just whatever's there in the smaller percentage, and solute is the larger part. Usually water's the solute because we're dissolving things in water. Because if you remember, water is known as the universal solvent because of its polarity, which is caused by the difference in bonding, which gives rise to hydrogen bonds. Oh, we got all kinds of stuff happening with water. You know how it is. So here is a really simple little basic problem. And look, there's water. We can still talk about it. So 15 grams of salt is dissolved in 350 milliliters of water. Okay, so what we're being asked here is what is the concentration of the solution? And so what we do is we just follow these really simple steps. We need moles over liters. And so we take our 15 grams and we go back to unit 1 and we switch it from grams to moles, and we get 0.257 moles of salt. And then we take our 350 milliliters of water. 1 liter is 1,000 milliliters. Cross off, and you get 0.350 milliliters. Sorry, I didn't mean to confuse you. And then you take 0.257 over 0.350 and you get 0.73 molar, and that's your concentration. And so that concentration is important because I can look at that and know immediately how much stuff is in there. Now with a salt solution, that doesn't really matter that much and it doesn't mean that much to me. But with something like hydrochloric acid or sodium hydroxide, acids and bases, concentration becomes really, really important. And that's something that we need to really think about. Another type of problem that you would run into with this is you can kind of reverse it. And so, let's see, 25 milliliters of a 0.15 molar calcium chloride solution contain how many grams of calcium chloride? So we're basically flipping the script here and going backwards where we have the molarity right here, 0.15, and we want to know how much mass of calcium chloride is contained in that solution. And so again, we take the milliliters and we switch them to liters. 25 divided by 1,000 is 0.025. I'm not scared that that's a small number because 25 milliliters is a real small part of a liter, and that's fine with me. 0.025 liters, 0.15 moles per 1 liter, so that'll help me isolate moles. So in this case, I'm going moles, and then I'm taking the moles to grams, and then here I get 3.75 times 10 to the negative 3 moles of calcium chloride, which is not a lot, but then I multiply it by grams over 1 mole. My moles cross off, and it's like 0.42 grams. So it's not a lot of the solution, so we wouldn't expect it to have a lot of mass there. So those are 2 really easy ways that we can use molarity.